is going to explain the last elimination method, and it would be the method that would require the most steps. I'm going to use this page in your notes. It's page numbered 7, and I'm going to do examples 1, 2, and 3 on this page. I will not do number 4. We will skip number 4. And then the problem set, the first problem set assigned with this would once again be a puzzle where you have the answers. So I would like for you to do the puzzle problems, show all of your support work, and scan that to me. And then I will review a few of the problems on the puzzle before I end the video. But let's go back. Let's start with number 1. And I've copied number 1 on paper right here for myself. And here are the answers. The answers are both fractions. The results, the solution, they're both fractions. X is a fraction and Y is a fraction. But I need to show you how I got those answers. So the key trait to notice here, when I analyze my system, I no longer have natural additive inverses built into the system. So my job is to now create additive inverses so that I can then just add the equations together and use the elimination method that you've been practicing earlier in the week. So looking at this particular system, I could choose to eliminate X, but when I look at Y, I've got a positive 4Y and then negative Y, which means if I just take this second equation and multiply each member of the second equation by positive 4, I'm going to create additive inverses on the y's. So I'm going to do that. I'm going to multiply each member of equation number 2 by the orange 4. That's going to give me 8x minus 4y equaling negative 24. And then I'll copy the first equation underneath this. So here's my first equation, just copied over again. And now this becomes my new system to solve. This is my new system to solve. And notice now I've created additive inverses on the y's. So I'm going to add the two equations together, just like we've been doing in the previous homework problems. And I'm going to get 9x equaling positive 6. I'm going to divide both sides by 6. And that's going to give me x equaling 6 over 9. I'm going to remove their common 3. And that's going to result in a value of x equaling 2/3, which is what I expected to get right here. Now my job is to find the value of y. So my next job is to find y. So it's important to stay organized and it's important to show your work. And I will go back to either original equation and I'll just go back. I'll just take the first equation. So here I've got x plus 4y equaling 30. And I'm going to let x become 2/3. And 30 is going to need a denominator of 3 because I'm going to have to subtract 2/3. And I don't want fractions. I don't want decimals. I want fractions. So on my next step, I'm going to have 4y. That's going to end up as 90 over 3. And I'm going to subtract 2/3. So that's going to result in 4y, 88 over 3. I'm now going to divide both sides by 4, multiply by 1 over 4. And therefore, y results in 22/3 when I remove the common 4s. The 88 and 4 share 4. So the value of y is 22 over 3. But the big takeaway from this problem is, this is the new piece. When I analyzed the system initially, I noticed that I don't have additive inverses in the coefficients. So my job is to create that and make it happen. And the more you do this, the easier it gets to recognize the easiest way to do it. And for this particular system, since I had a positive and a negative y, I just simply chose to multiply the second equation by positive 4, and then that created the additive inverses for me here. Let's look at problem number 2. So here's problem number 2. And the result here, x is 4 and y is 1. And I would like to go through here and show you how I got that. So when I analyze the equations, once again, I have no additive inverse coefficients. So my job is to create that. And for this particular system, I'm going to have to multiply both equations by a number in order to create the additive inverses. Once again, I'm going to go for eliminating y simply because I've got a positive y here and a negative y here. So I'm going to make both of these y's have coefficients of 12, positive 12 and negative 12. So that means I'm going to take the first equation and I'm going to multiply the first equation by 4. And let me recopy that. So each member of the first equation gets multiplied by 4, And 19 times 4, I need to do that. 19 times 4 is 76. So that's my first equation. And then my second equation, I'm going to multiply both members of the second equation by 3 because I'm going for this negative 12 right here. So that gives me 9x minus 12y equaling 24. So this now becomes my new system for solving. Notice that I've got the additive inverses on the y's. So when I add my two equations together, I get 25x's and 76 plus 24. Hold on, let me get my calculator. Gives me 100. I divide both sides by 25. The value of x is 4, as I expected at the beginning. And now my job is to find the value of y. So to find y, I can go back to any of the equations above. I'll just go back up to the top and I'll just choose the first equation because it really doesn't matter here. So I've got 4x plus 3y equaling 19. I'm going to let x now become 4. So that means that this becomes 16 plus 3y equaling 19. I subtract 16 from both sides. 3y equals 3, therefore y is 1. So the solution to this system is the ordered pair x is 4, y is 1. If I were to graph the two lines, they would intersect at the point 4, 1. But we're not going to do that. That's not the object here. The object here is to recognize that you don't have the additive inverses. You need to multiply by the necessary factor so that you create the additive inverses, and then you carry on with the skill as you have for the past few days. Let's look at number 3. So number 3, analyzing number 3, once again, no, you don't have the additive inverse coefficients at the start. So once again, I notice I've got this positive 3y, negative 5y. So I'm going to go ahead and eliminate the y's by making each of them have a factor of 15, positive 15 and negative 15. So that means I take the first equation and I'm going to multiply each term by 5, and then the second equation, I'll multiply each term by 3. So my first equation becomes 25x, positive 15y's, and that's 60. And then my second equation, 12x minus 15y, and 17 times 3 is 51. So this becomes my new system. Notice that the whole purpose in doing this is to create the additive inverses right here. So when I add the two equations together, I get 37x's, and that's going to equal 111. And when I divide 111 by 37, x is 3, as I expected it to be up here. So x is 3. I go back to either original. My job is to now find y. And I'll just go back to the first equation. And I will let x become 3. So that gives me 3y. That's 15. 12 minus 15 is negative 3. Therefore, the value of y is negative 1. So that's basically the skill. And I would like to look at the problem set and possibly do one of the problems from the problem set with you. So what I would like to notice, what I would like for you all to notice on the problem set here, let's look at number 1. I think in number 1, it would be easiest to take the second equation and multiply each member by 2, and then you'll be able to eliminate the y's. Looking at the third equation, I want to do this one with you slowly on the video, but I want to go through and look at just a few of these before I do that problem. And problem C, I've got the positive y, negative y, so I think I would just simply take that first equation and multiply each member by 2, and then you'll have positive and negative 4y, and you can carry on. So what I would like to do now is look at a problem like letter B. So notice in letter B, I've got positive x's and both y's are negative. So the problems I've done so far, I've had at least alternating signs on one of the variables, which allowed me to just solve or just multiply by a positive number. When I have this scenario, and I'll get a piece of paper and do this, let's look at B together. Here, for letter B, and this is letter B, what I'm going to do, I'm going to choose to get rid of the x's. And when I do that, I'm going to take this second equation and I'm going to multiply this second equation by -3. So let me recopy the first. Here's the first equation. And when I multiply each member of the second equation by -3, notice that that's going to give me the positive 3x and negative 3x. So sometimes you need to multiply by a negative number in order to create not only the matching numerical coefficients, but then you need to create the opposite signs. And I'll go ahead and finish this problem up, but that was the only thing that I wanted to explain on the video, is that here I needed to multiply by a -3 in order to create the inverse. So that's going to give me positive y equaling -2 when I add all of these together. And I will let you carry on and finish that problem by yourself, finding the x partner. Let's look at letter D. Actually, no, let's look at letter E. Let's look at letter E on the video next. So here's letter E. Let me copy this. Letter E, I've got 2x plus 3y equaling positive 7, or 3x plus 4y equaling positive 10. Let me make sure I copied that right. Letter E. Got it. Okay, so looking at this, everybody's positive. I have no alternating signs on any of the variables. So I could choose to eliminate the x's, or I could choose to eliminate the y's. It really does not matter. If I decide that I want to eliminate the x's, I would take the first equation, I would multiply each member by positive 3, and then I would take the second equation, and I would multiply each member of the second equation by -2. And that's going to create the additive inverse coefficients that I'm going for. So here I'm going to have 6x, 9y, and 21. And then my second equation, -6x, -8y, and -20. So not only do I need to analyze for the correct factor number to multiply by, I now need to analyze for the correct sign as well, so that when I add these two together, I'm going to end up with eliminating one of the variables so that I can carry on with my system and solve. And I will let you take that from there on your own. And I think let's at least look at setting up letter D. Well, actually, letter D wouldn't be that bad. Letter D, I think the easiest thing to do with letter D would be to take the first equation and multiply the first equation by -5, and then that's going to give you -5x and positive 5x, and when you add those two together, it's going to easily eliminate. Looking at letter J, since it's on the screen, if I choose to multiply the second equation by 4, that's going to give me positive 4x and -4x, and then I can carry on. I think I'm going to let you all take it from there on your own and let me know if you need my help.